So this is the not so short introduction, or based on some of that, plus a lot of other things. So one of the reasons we do this, you can do whatever you want in Word if you have enough patience and enough resources, but the average thesis is well beyond what any publisher would want to do in Word. Okay, the average thesis has 6 chapters, 2 appendices, 14 sections, 196 charts, 30 some figures, 50 some tables, and nearly 100 cited works. In fact, lots of theses have much more than that in any of those. That's not something that you really want to load in one document and hope Word does not somehow go crazy and destroy it. It's also not something you want to work on as one document. Even in LaTeX, I would not recommend your thesis be one file, right? Just like your programs shouldn't have 100,000 lines in one file, right? You break them up into modular pieces and you work on little pieces and you work it together, right? That's the way we develop stuff. That's what LaTeX is going to help you do. And the data for a thesis has got something, depending on how you look at it, might have 40,000 raw data files, 8,000, right? Hundreds of charts, whatever. Before you decide which are the final 100, you might generate hundreds of plots, okay? And you want to figure out what that is. Those are the numbers, by the way, from my thesis. So I don't know if this average. I couldn't find anybody that had averaged amounts of data. So my thesis had 800 figures or charts in it. It was ridiculous. No, I'm sorry, it had 300. It generated 800 and only put a couple hundred in it. My thesis is like that thick. It's a book. But you also want to be able to regenerate things in your thesis when you need to, right? So the idea of loading a bunch of data into Excel and manually making the plots look good might work for a paper. It's really not how you should approach doing stuff in your thesis. You are mostly computer scientists. If you want to generate a plot, you should have code to generate it, right? So that when your data changes, because inevitably your first time through the experiment isn't right, your second time probably isn't right, your 12th time you might finally nail it, but you don't want to keep doing that plot over and over again, spending lots of time by hand. If you start up front with the attitude, I'm going to generate this stuff to make it work, you're going to generate your complexity by using Python, shell scripts, awkset, whatever, all of your tools. And then you're going to use non-interactive things like matplotlib in Python, GNU-plot, MATLAB, LaTeX, right? Where you can write code to make your plots do what you want. Okay? Yes, you can do it in PowerPoint or in Excel, but that's not going to be in the long-term and efficient way. You might find, and I often do, mix the two. I will do part of this, the data analysis, and then I might do a final plot in Excel, even though the draft ones were all done in something else, because mostly when I have to give it to my sponsors who want it in Word and Excel, I will do it. But otherwise, you can make good things in other things. It just takes a little bit of learning. But the other thing that's important, which is where we're going, is a document preparation system that decomposes and compartmentalizes writing, like we decompose and compartmentalize code, integrates with the tools pretty well, and then automates formatting and numbering. You really don't want to worry about where should this figure go, what number is it, and how do I refer to it later? Because if I add one figure, and if you've never had the fun of inserting a figure in Word and having everything break, I can let you go ahead with that. But believe me, when you get to a thesis, I have had friends who call me like the day before their formatted thesis was due, and they're in another PhD program on campus, and it's like, Word has eaten my entire document. Can you fix it for me? And luckily, I'm good at Word. I can actually do some low-level things and get it to work, but you don't want to be doing that path, right? So with the right variations in LaTeX, the other thing that's very easy is I can literally have a document, change one line, and change it to any one of these 3 formats. I can change the style of references from IEEE to APA in the click of one line of text, recompile the document, and I can change it to match somebody else's standard. So this is also very useful for dealing with places where, well, I submitted over here, it didn't get in. They had this style rule. Now I submitted over here, I have a new style rule. I just change a couple lines, I can continue to reuse the work. And LaTeX is extremely powerful. Everything you see on this screen, except for these figures here, which are actually photographs, but these tree diagrams, this automata, finite automata, all these math equations, all these are typeset in LaTeX as structured document processes, not like done in some drawing tool and imported. LaTeX has very powerful ways of doing all kinds of graphics and importing them into things. So in LaTeX, we have a root file that can then include other files like intro, results, and conclusions. inside results, I can have other sections, so I can decompose it like what I would literally have subroutines. I can have little files I include. And if you've ever played with the C preprocessor macros, that's actually closer to what LaTeX is. LaTeX is a macro language written on top of a compiled, an interpreted language called TeX. The underlying language, LaTeX, is just a bunch of macros on top of it. The underlying process allows you to do a bunch of stuff, and then all these are macros. And I can do things like include figures in PDF. I can include figures in PNG. I can actually have my LaTeX, as it's generating, call scripts to generate new figures on the fly. And if you really want to get way out there, and once when we were doing a very large project where we used LaTeX, I actually had, when you compiled the documentation for this large library of code, it generated C++ headers and .h files and stub codes for every method and stuff that was documented. In the documentation process, it generated the code stubs. So, in fact, the process for the library was you wrote the documentation and you used it to get your stubs. Otherwise, the stubs would not have a hashtag that would match the documentation, and then the next part of the process review would reject it. Right? So LaTeX is Turing complete. You can compute anything you want inside of it with enough effort and do some weird things. But we're not going to go down that path. A bunch of resources. So CTAN, the Comprehensive Tech Archive Network, has a whole bunch of places for good packages and tools. So if you see, oh, where did somebody get this package, and they don't mention it, you probably just go to CTAN and look for the package and you will find it. The TUG, the Tech Users Group, has lots of stuff for both TeX and LaTeX. The LaTeX Project Wars has lots of stuff that is just LaTeX. A couple of documents if you want to read a not so short introduction and some video tutorials. And if you really want, you can actually read the LaTeX source code for all of it. It's written in the language called TeX. So if you read the TeX book, which is the base core language, you can do lots of stuff and figure out what they're doing. You don't have to worry about going down that path, but sometimes it actually helps if you're a coder and you can look at the source and say, oh, now I know what that error message means. I can fix it. TeX was introduced by Don Knuth in the late 70s and stopped working on the 89s. It was really designed to allow decent typesetting by the authors. Before that, which is before my time in the journals paid professional typesetters to make things look good when they published them. And publishing was a very slow and costly process because they had these specialized professionals. By the mid-80s, when I started mine, I did everything in LaTeX, or actually in TeX because it was before LaTeX. And then you could typeset stuff and make some really nice looking equations and things that look like they were going to go on. It's very low level, very powerful, and it is frozen in development. There's been no advances since '89. For a number of years, Knuth had a bug bounty, and it was actually an increasing, I don't remember what the increasing price was, but if you could find a bug in TeX, he would give you money and send a check. I tried twice, neither of mine were bugs, they were design features. But after 4 years of no one even trying to claim a bug bounty, they decided to freeze it and say, it's good. No more things. So it's a long-lived program. It's actually still in use, just no longer being developed. In the early 80s, around 83, 84, just as I was in my PhD program, LaTeX came out by Leslie Lamport. It was designed to make TeX easier for non-techies to use because the macros made it a whole lot easier than the raw TeX. The current version is 2E. It is moderately difficult to extend. That's what they say. I don't know if you know TeX. It's easy to extend, but if you don't know TeX, it's impossible. It's sort of like extending a library in a language you don't know. But how is it pronounced? It is not LaTeX. Okay, this is not gloves. It is not plastic. It is pronounced LaTeX or LaTeX, as in Bach. But it's not LaTeX. Knuth, who was the inventor of TeX, says it's like Bach. So it's Tach. I don't know. LaTeX. And Leslie Lamport says, hey, whatever. As long as you use it, I don't care what you call it. So getting started, you will need a TeX installation with the appropriate interpreter. So it is an interpreter on top of this macro language and a .tex file, although it can be named other things. People sometimes call it .ltx, but the common is still to use the actual raw TeX. And you can also have, almost always have to have, if you're using LaTeX, external style files. Some editor, personally I don't believe in this, because if you have a powerful enough text editor, you can do it and whatever. I strongly, however, discourage Notepad. Get a real text editor. And then BibTex, which will be doing stuff. So installations, generally any Linux installation comes with Latex if you install a broad set of packages. If not, install the package called Tech Live, although there's no space in it and the X is lowercase, it's just Tech Live. In Mac, the most common one is MacTech, although personally I use Tech Live in Mac, on my Mac. I don't like GUIs. In Windows, there's MicTech, GhostScript, and TextCenter, and again, you can get all of that from the link there. And there's a bunch of extra packages that you can go about installing them. There are also some other things, so if you really don't want to install stuff, and if you don't want to work through that in the next week because you have your first assignment due in tech next week, you can simply use overleaf. There was another one called Share LaTeX, but overleaf bought Shared LaTeX. And then there's a couple other places like Quick LaTeX and Math Tools that will help you getting some balance between images in LaTeX. So if I wanted to do equations, I can actually use one of these tools, type in the equation, and get a figure and a PNG that I can include in a PowerPoint or whatever. But after a little while, you'll just go for your own version. So now let me go to it's not where I wanted to be. There we go. Okay, I give up. I can't see it. I'll just take this one over there. So this is overleaf. A very short introduction. You go to overleaf.com. I think that's what it is. Or is it overleaf.org? I can't. Can't see it? Okay, so is it overleaf or is it .com? Overleaf.com. Okay. So overleaf. So accounts are free if you get a free account. If you click on the link that I sent you, you get extra storage on their site, so you can get to it that way. I think you get an extra 50 megabytes. The one problem with the free account is you have two big limitations, which doesn't sound much like now, but eventually will be. I think you only get like 50 or 100 megabytes of storage, and you can't have more than 60 files in a project, which limits it to the kinds of things I do all the time. I have lots of papers I can't put in there because we have way more than 60 files, but is the other reason I find it limiting. It's relatively simple to use, so I won't go into a lot of stuff. You have a bunch of projects. When I click on a project, it will load up and it will show you a multi-plane view where, because this window is so small, let's see if I can grab it. No. So I'm splitting my view between seeing the text source code and the generated image. And if I go in and I don't know where I don't want to edit this. It's actually a paper my students are working on. But I can go in and make changes, and then I just click on the recompile button, and it will compile the LaTeX and show you the changes. So it's pretty straightforward to get. It's not WYSIWYG, because what you type is not at all what LaTeX. It will give you LaTeX output, but it's not what you. So once you've typeset it, what you see is what you'll get. This will produce a PDF. It looks just like that, but what you type over here is quite different. Over here is also a log message. So when you recompile it, it'll give you these wonderfully detailed messages over full box, 21 point whatever points, and then it'll tell me a line number. And if I click on it, generally it will show me, recompile it. It'll show me the line that's associated with, but maybe not because it's just a warning. And then you can see other log files. So you can get some debugging information when things don't work. I can go in and, let's just break something. Okay, so I'm going to, this is a figure. I'm going to go down here and I'm going to delete this last brace. Squiggly braces are really important in tech. So now I will recompile it. And it will say, oh, look, your file has some fatal syntax errors. Try compiling anyhow. Okay, fine. So it'll yell at you for certain things before it even happens. And then there'll be a runaway argument, and it's going to show you the line in the main file that included the file that included this, and then I go here. But it already was giving me the syntax error. So that's the good thing about this. It will check a bunch of your syntax as you do this. So if you're beginning to learn LaTeX, it will help you make sure you understand what that learning is. One last thing, which I think I've turned off, so I'm not sure if I can get it to come back on. No. So in here, I will show you this while I'm at it. You can actually get GitHub interaction, which you will want for this class. And then you can make it create a repo, or you can sync it with an existing repo. So you can also sync it with Dropbox or other things. And then there's a bunch of parameters you can set for how you want it to interact. But I want to get to the top level. So if I click on New Project, I can get a blank project. I can't read all those, but one of those will let you import it, and then another will let you start from something that has some predefined templates, which you can use for the beginning of this. And a lot of the features designed for beginners I've turned off in mine, so I can't see them anymore because they were just annoying when they would take over. They're always like, well, here's 15 templates. Like, no, I want my own file, so please don't bother. Okay, so that's a quick intro. I have a little bit more later, but I wanted to make sure you all seen that much before I go forward. So that will give you enough that you can get going for this week's assignment. Other thing about overleaf, overleaf is designed to make collaborative writing actually a little bit easier. So when you're working on a shared document, so underlying overleaf is Git. Every file is maintained in Git, and literally, if you're the only one using it, every now and then it will push a commit. If you have two people using it, every time a new person hits a key, it's a commit, right? So you might actually have a couple hundred or 1,000 commits because it's trying to do synchronization between two different people editing the same document. Now, so that I see some grimacing faces, right? Well, first of all, Git doesn't really care if you have 1,000 commits. It's not huge. But the bigger problem is that when two of you are editing the same part of a document, you're more likely to have errors. Part of what this should encourage you to do is if you break your file as the one I showed you, right, our main paper will have like 6 files in it. The main level paper, intro, research, result, we have a sort of standard paper we make up, and then you sort of have an agreement. I'm editing this section, you're editing that section at the same time, and then Git doesn't make lots of stupid commits because you're each working on separate files. It only does it if you're literally like following each other typing. You add an E, they delete the E and whatever, then it obviously will be a little bit less efficient. I already covered those. So making your first LaTeX document, start with a skeleton document, write your text, annotate the appropriate parts, interpret through the program, and fix any errors and modify it. So it's actually older than, so people will sometimes say it's a lot like HTML. Well, that helps people understand it. HTML is a markup language. TeX was the first markup language. And LaTeX is just an extended version of it. It's interpreted, and its error messages, just like error messages in HTML and some other languages, right, can be somewhat cryptic because it's not really good at understanding where you generated the error that eventually led to something not being allowed. So it's always before or at the point they tell you, but it's not always at the point they tell you. Sort of like C and braces, right? You forget a brace in C and the error message will be sometime later, or a quote or something else, right? So just be a little careful when you try and interpret them. So given a very simple LaTeX document, this is actually not even minimal because I have a bunch of packages, I can compile that and then get an output file. Your basic structure starts with the word document class and then some type of predefined structure like an article. Include some packages, begin document, document contents, end document. So most things in TeX work with, in LaTeX, begin with begin and end, because that's the syntax that LaTeX is a macro. So literally the word /begin is a macro that takes an argument. So I can /begin anything and the macro will then go do the various things. Anything that starts with the backslash in TeX is a command of some kind. There are some commands in raw TeX that don't have slashes. Every LaTeX command has a slash. Some raw TeX ones may or may not. You can do lots of things for images, equations, whatever. There's a bunch of packages. Here's a sort of relatively standard set to include that gives you more advanced math fonts, some advanced math symbols, basic graphics, including dealing with some spacing, adding it so you can do multiple types of citations, which is you don't really need, but it allows you to have a more fancy kind of citation reference so I can refer back to it. And then hyperref makes all of the citations in your paper, so when you have the citation, it's actually a hyperlink, and if you click on it, it'll take you to bibliography and show you the actual thing being cited. Formatting text, so many of you are looking, I want bold text, italics. So there are /techbf, /emph, and /underline. And then I can do things like /large, /larger, /small. You'll notice all of these last ones are, the argument is inside the squiggly braces, and for the first ones, they are outside the braces because they're actually macros. Don't let consistency mess with you. These bottom ones are actually tech commands. The top ones are actually LaTeX commands, so they're actually macro arguments. And there are versions of them called that go inside the braces, which would be /bf, /it, and I don't know how to do underline in LaTeX. I don't do it very often. So some other things about spacing that's important to remember. Many spaces equal one space. Once you have white space, any amount of white space is the same amount of white space. So you can make your program readable because you know what? It's going to ignore spaces. Unfortunately, if you don't have a space between two things, there's none, then it's a new word, right? Just like you were typing in C. If you want to actually force a new line, you can use the command // which is / to generate a new line. So the opposite of using it in Unix where it's that allows you to eat a new line, this one generates one for you. If you hit return twice for a new paragraph, so unlike normal Word where you hit return and it starts a new paragraph, in LaTeX, every line can have a carriage return at the end, and it's not a new paragraph until there's actually a blank line between the sections of text. This is actually also very good if you're working and you're using something like Git or any other editor, and you're going to have multiple people working. If I actually put one sentence per line, then I am less likely to have merge conflicts in the same sentence, right? And generally, people enter a sentence. If I edit a paragraph and two people edit anything in that paragraph, then I get a merge conflict. So it's better to keep them separate lines. There's a command to force new pages. It's called new page. You should avoid it. Tech actually knows a lot about layout. If you really have to use it, there's times you can go ahead and do it. Everything in tech, and I'll come back to that, is based on boxes and glue. Glue can affect layout, stretch, and shrink, and it'll do some things that in the beginning you might say, why will it do that? Tech will work very hard to make sure you never have widows and orphans. You don't have a line that starts a page all by itself from the last sentence of a paragraph, right? And you don't have a sentence that starts with only one line and not in the next paragraph. It will automatically flow those around and say, no, that's really bad style, we'll make it look good. Quotes are done with the actual single grav and quote, right? Not double quotes. If you put in a double quote, it always faces one direction in LaTeX and it looks weird. Tech is designed to have different shape quotes and unquotes, and so use them. Anything that starts with a % is a comment from that point until the next carriage return, till the end of the line, right? So if it's in the paragraph, it's going to be put together. Like any language, there are some special characters. So /, $, the double braces, and % can't be written alone. If you want to actually have a $ show up in your text, you have to say /$. $ puts you in math mode, which will then allow you to type equations. And it has to be ending in math mode to get you out of it. You can have things like quotes. You can have sections in your document. So section, subsection, whatever, right? You tell LaTeX what you want it to be, a section, subsection, subsection. And depending on how things are initialized, it will do the numbering for you. You don't have to worry about that. It'll keep track of all those. Things like lists are done with environments. So I can say begin enumerate, item, end enumerate. Okay, you don't have to worry about random paragraphs getting a new number or other random things. It only gets a number if you say /item. There are ways to make numbers start at some point you want. All of those are in the more advanced features. And if you just want bullets, you can say itemize, and you get various items. Graphics. Most good documents will have some level of graphics. There are many packages, but the most commonly used is graphic X. And then I can do something like, say, include graphics, height 50%, width 50%, file name.png. As its name implies, this will read the file name.png and scale it to be 50% of whatever its designated size was. Now this is tricky because most PNGs don't actually have a size, right? So it will use some default pixels per inch, which is part of the PNG standard, if there is one, and then it'll decide. So this was supposed to be 72 pixels per inch. There's 3,000 pixels, so it's a really big image. It won't fit on the screen. You can, instead of using %, which is really a bad thing, I would use like 0.9 times column width. So this weird syntax here is a number times column width is a constant that you don't know what it is, but it changes for every document. That's multiplication, two numbers next to each other. So that makes it most of a column width, but not quite the full column width. Or I could actually just be explicit, make it 3.1 inches. 3.1 inches might be fine if I have a single column page, but if I have a two column page, actually it's probably still okay because they're normally 3.3 inches wide. But, so this one scales with the format. This one is good in a single column format, but otherwise wastes a lot of space because it's a really small figure. In general, you have include graphics, attribute equals value for all the different pairs, and then some graphics you want installed. LaTeX supports EPS, encapsulated PostScript, also includes JPEG, PNG, and many, but not all platforms include support for PDF. So if you use PDF LaTeX, it'll support PDF. If you use just LaTeX, it will say, no, I'll take EPS, PNG, or JPEG, but not PDF, because it doesn't have a built-in PDF interpreter. So everything in tech, every character, every period, everything is a box. Underlying deep in the tech rules are a bunch of boxes. Every character is a box. Everything is put together, and boxes are then joined with glue that allows them to stretch and whatever. One of the key concepts then when I'm trying to include graphics, so if I'm trying to include a file that is like a page, if I don't tell LaTeX anything different, it's going to say, well, this is an 8.5 by 11 sheet of paper. You told me to make it a 4-inch figure, right? It's going to take the entire page and try and make it a 4-inch figure. If you wanted to do something else, so if I make my PDF or my EPS have the right bounding box in the file, it'll do the right thing. If not, I can actually tell it a bounding box and say using a bounding box that is in whatever units the file is in, 1, 2, 20, 10, 20. Right? I don't know what units those are, but it's whatever the units in this file are. If it's inches, millimeters, points, I don't care. So you can actually still include them. And there's a bunch of other parameters like width, height, aspect ratio, scale, angle, trim, clip. So I can actually trim a part of the figure out in LaTeX without actually cropping the file. I can just tell it to trim off pieces and do things with it. So it's pretty powerful. There's actually an entire graphics generating library. I won't go through that. Just to sort of get a feel, so here I have a simple document, a begin center. I have some text. I include, so /par tells it to start a new paragraph. Big skip says add some white space. It's one of the many commands to skip in vertically. Include graphics with some parameters, paragraph, and more text to see where it wraps. You'll notice here, when it gets rendered, you have a box, the text is underneath it. So if I now go back and I change that, so I tell it to clip the box where I have a trim box, you'll now see it's trimmed the width of the box, but LaTeX also did something different. It moved the words that are after it to be before it. And that's because it decided here, with a big skip and a full-size box, the placement of this paragraph looks better after it. And here, it decides to move it above it. This will be annoyingly frustrating to some of you who are trying to get it to look just the way you want. Tech is going to try and to do things in various ways. My recommendation is, the real problem here was this was just trying to include graphics. If you want to do figures properly, you should be using begin figure, which is the LaTeX command to float figures. So LaTeX will, by default, when you put in a figure, this says put a figure top of the next available page. If that's not too ugly, otherwise put it here. That's the T and the H. Top here. And then I can have centering, include graphics, and I can put a caption in it, and it'll do this. And if you've noticed in lots of scientific articles, most of the figures are actually like at the tops of pages. Every now and then at the bottom. That's a convention that's been around for a long time, and LaTeX will support those, and it'll float the figure. And if I really want it to be here, I can say here, here exclamation, and force it, try and force it. It turns out that there's actually 3 levels of forcing. You can use capital H's, which is a little stronger because it means you're yelling, and you can have 2 exclamation points, which really is being emphatic. And sometimes it will still not listen to you. It will say no. What you're asking is just too ugly. And that's when sometimes you just have to add some other things. But in general, it knows what it's doing. It's trying to help you make your paper better. So there's a couple of placement things you can do here, top, bottom, place it on a page all by itself, and try and override the other departments, even if LaTeX thinks it's awful or really awful. References, so when I refer to something, I can have a section. then I can have slash label a section and then some text. So this label, arbitrary label, can now be used later to refer to whatever number the section was. Right? So you never say in your text, in section 2, you say in section /ref arbitrary label. Right? The previous section was this, that's putting in a sentence, but normally you say in section, and then normally, in fact, like I have down here, I use a tilde and then the reference to the thing I want. So here's referencing an equation. The tilde is a non-breaking space. It looks really bad to have in section and then the number 2 on the beginning of the next line. So it's saying, no, you can't have a break between these two things. Equation reference comes from one of those math packages, and when you go to do that, it will actually make sure it's referring to the label that was in an equation, and I'm actually not sure. I probably didn't need the equation. I probably could have said Einstein is associated with /EQ ref, and I think it'll actually say EQ tilde dot, right? So I think this is redundant. I forgot to recompile this one. So there are two things about tables. First, there's a table, which is another, there's a letter missing here, float environment. So tables also float, and tables have an even stronger preference to be at the top of a page than figures, so there's a preference when we're going to lay stuff out. And then inside a table, there are things called tabular, which is the environment that actually does the layout. So just like figure and include graphics, we have table and tabular. So it's sometimes a little confusing. So tabular just does the raw stuff. And when you go to do that, so the environments have some, so this is vertical bar, right, vertical bar, left, I'm sorry, vertical bar, left, vertical bar. That produces something in here that has a vertical bar, a section of text that is right justified, a vertical bar, a section of stuff that is left justified, and then another vertical bar. That's where those lines come from. You're really telling you sort of draw a vertical line here, do some stuff justified, whatever, do another vertical bar. You don't have to have any vertical bars, you have to have space between them. You then have H line, which says put a horizontal line. Then you have a bunch of data. This C line says to draw a line between only columns 2. There's a whole bunch of details and go this. So in the references, if you really need to figure out how to do this, there's actually some websites that will generate tables and figures for you. It's very, very powerful, but the more power you want, the more complicated it becomes to do. You can do things where you have conditions and you start generating complicated tables. It's ideal to generate code so you can generate a table from any new run. So if I wanted to do something like this, there's actually a very nice package that I recommend in your beginning. It's called CSV Simple. This package allows you to basically read in a CSV file and tell LaTeX how to format it for you. So if your code can generate a CSV file, then your document will always get the newest CSV file and just recompile it every time it does this. So here I've said, I actually have two examples here. I have CSV auto tabular test.csv. So whatever's in test.csv will be loaded in, and I'll show you what that looks like here, right? So the default for auto CSV is if your CSV file has a line of names, that's your first row separated by boxes on both sides, and then it has columns of data, which is all right justified. That's the only dumb thing. I don't know why they like to right justify things. Numbers should be left justified, this side. But you can fix that with a single command. Or I can actually read a much more complicated table. So this is actually reading the same thing, CSV, test.csv, and I can actually choose column I, which is column 1, column 2, and column 4. So out of this I've gotten time, relative time, and Y position. Oh, and in this one I can name them differently than what's in the document, right? So in a couple of lines of LaTeX, you can now make this binding between code generating tables and your thesis having tables in it really easy, because you just generate CSV, which lots of things have libraries to do. If you want to get fancy, you can make your Python scripts output the actual table structures. I just don't find it worthwhile. You can just do it this way. If you want, there's also this thing called tablegenerators.com, and you can sort of tell it, I want 3 columns, 2, whatever, and it'll build the LaTeX code for you, which you can then insert and fill with numbers. Math mode in LaTeX. So math mode, things in math mode don't look the same. So if I had 3 + 1 in normal text, it would look like this. and it would become italicized and slightly different spacing in math mode. To enter inline math mode, you use a single $sign, so I can say when $x equals $3, comma, fxy dollar rate reduces to whatever. If I really want to do standalone math mode, I can use the original tech version, which is /square bracket, which is a little bit weird because // means print me a new line, $$ means show me a $sign, /square bracket means start equation mode, which puts offsets and whatever. Better to use, in my view, begin equation because these are way too easy to mess up. The only thing I like about them is they do square bracket matching in Emacs, so it's easy to match them. White space in math mode is generally ignored except for where it's affecting operators. So if whether or not I add extra spaces doesn't matter, I can break them up. Math eats spaces. Many symbols contain natural spacing, and I'll show you that in a second. And others need to use specialized spacing commands. So inside math, I can do /semicolon, which is a quarter point or a quarter character spacing, comma, /comma, which is half character spacing, and /space, which is a 1 character spacing. And they're all approximate because they're all subject to glue. If I want to put text inside math mode, I need to use /text IT braces or text RM for IT Roman or bold, which I already showed you. And you can tell when people don't use their LaTeX math mode right. So if I said $myfun.or /textit myfun.or squiggle braces /text, right? You'll notice the weird spacing here. After the M and before the Y, after the F and before the U, there's extra space, right? Hopefully you can see that this looks, come on, where's my mouse? Right? This, come on, I lost my mouse. Is my mouse over there? So this spacing should look a little weird, right? The characters aren't quite right. So that's a sign that it's not in the math mode. But when I put it in inside the text italics or the text Roman, here it's Roman, here's italics, and the spacing is right, the whatever. So just don't type math text inside of math, it'll do some weird things. So this is, most math is built in. The AMS math package defines a whole bunch of other things that will allow you to get to some things. So these next pages I'm going through really fast so you can sort of see them, but you can do any kind of math you would ever see in any textbook or whatever. If you've seen it, you can do it in LaTeX. It's relatively straightforward. To get all these weird symbols, they're all built in. So something like the sum from I equals 0 to infinity, /sum underscore I equals 0 superscript infinity. Right? Literally you can do this. Once you get used to this, people will actually write in reviews equations like this. This syntax has actually now been adopted in a bunch of other places. So if I write web pages using MathJax, it uses a LaTeX-like symbol. Lots of various characters you can get to. All the Greek, many of the capital Greek, any math symbol that you can imagine, a bunch of types of arrows, some more weirder symbols, things for typing, and just for fun, you can have a couple of suits of cards. There's actually a whole bunch of, if you want emoticons, there's an emoticon library now for LaTeX. You can just put them in your papers. People want smiley faces. A bunch of brackets or delimiters, and many of these are large delimiters, so I can do things that have very large braces. I can have square brackets or squiggly braces that take 5 or 6 lines by using them in the right combinations inside the language. All kinds of accents, so I can have obviously the normal things like hats and check marks and grave and acute, but I can also have bars, vectors, dots, double dots, the little breves, the little tildes. All of those are typable in LaTeX, and then a bunch of other constructions like putting arrows over multiple symbols or over an entire set of equations. You can do all kinds of stuff like that. So just as a couple of examples, you can type an equation, and then you typeset it, you get something that actually looks pretty nice. When you say fraction, it knows to put the first argument in between braces on the top, the second argument is on the bottom. Things like superscripts and subscripts always take one argument, so if I want multiple symbols, then I need to put them in, like, so here I wanted P with a subscript of gal as Roman text, so I have P underscore open brace Roman gal close brace, right? There's multiple ways of doing those kind of things. If I want multiple equations lined up, I can use equation array, and there's a couple of other forms of this. but I can say, here, type these sets of equations with, and I have these ampersands in here. These are the lineup characters, which were also the lineup characters in tabular. So this is going to make it type out in a way that gets you a nice equation with all of those lined up. If I use the equation array, every one of those lines would have a number. If I put a star, then it'll suppress numbering. So here's an equation array with 2 ampersands, right? And so the equals are lined up because it's between the 2 ampersands. And this allows you to do this nice lined up equation, both of which have numbers. Here I've actually added a label that says label E3. So again, I don't ever want to refer to equation 3.3. I can refer to label E:3, and then this will be 3.3 right now. But if I add one more equation before it, or I change the section and I make this section number 4 because I added a new chapter, all of those numbers automatically change. And we'll see about that in just a little bit. And if I want to typeset algorithms in my document, pretty easy. The one I use most commonly is algorithms 2e. There's also algorithms x. And then I can write in LaTeX a bunch of things where I can begin an algorithm, set a line, have some data, say I'm going to have some results, and then go through a while loop. And then I get some nicely typesetted thing that has like my while loop with the word while connecting to the end of the while, right? So people can see the structure and whatever, and do a whole bunch of stuff. There's other modules where you can do it, and you talk about specialized keywords. So tons of those kinds of things. So quick introduction to some of the high-level things. Debugging LaTeX. Generally when it fails, there will be an error message, and it will look a little bit like this. The date today is whatever, which is nice to know. Unfortunately, I can't spell, so that's not actually the word today. That's the word toady, which is actually the error, right? And generally, in this case, it said, I don't know, undefined control sequence. Right at this point, I don't know what that word means, so it doesn't know what that is. It'll tell you. It's not always perfect. There'll be some other places. If you get a LaTeX error, guaranteed you are not the first person to get that error. Try Googling it. You'll get lots of help for that. Package mismatches can actually be really difficult. Sometimes you'll get an error that refers to something you don't even know you used. Okay, the most common way that happens is you have 2 packages that are fighting with each other. Both of them define the word algorithm. But you can only have one macro called algorithm. So if 2 packages define algorithm, they're going to complain. And what's odd is, like the C preprocessor, it doesn't actually process the macros until they're actually used. So the fact you included the package doesn't cause a conflict. It's when you go to use them, and actually, if they were both called algorithm, when you first use it, it'll say there's a conflicting reference or something like that. But if I use something that's inside of one package, like the C preprocessor macro, the last macro defined wins. So now my algorithm package is expecting its argument, alg1 to do something. But the new package defined alg1 to do something completely different, and so it just blows up and does weird things. Macros in LaTeX are actually pretty simple. If I want to have, and I recommend this, doing things like new command my name for my system name. This is especially true when you're not even sure what you're going to name your system. You're writing the paper. You should have a name, but you might change that later. Decide you don't want to call it that, right? Your advisor might say, yeah, I want to call it something fancier and change it to some like word they made up. My students hate it when I do that. But, this way you can change it everywhere in the document without actually like trying to do a find and replace or whatever. You can have comments. So this is actually a tech style thing. So this is a long thing, which means it'll leave paragraphs, and it has one argument. So after I type long comment, open brace, until the matching close brace happens, it'll leave everything in your document. So you can take things out really easily. You can do things like, you get tired of saying bold font, whatever, right? Text BF, you can just say BT and take one argument, and so I can say /BTIF. Right? Now it's going to make the word if bold. Very simple to add your own arguments. If you wanted 2 things, if I really wanted to do a vertical fraction and I want to force it to be a vertical fraction, I can say /ensure math, which if I'm in math mode does nothing. If I'm not in math mode, puts me in math mode. Because if you're used to doing stuff and you keep forgetting it, it'll break it. And then it does a fraction. And a whole bunch of things like that. So if you want to include fancy little math in PowerPoint and you don't want to fire up all of your LaTeX, which I sometimes do when I'm doing slides, there's a couple of different things like TechClip, TechPoint, and these will let you get a PNG or a PDF of a LaTeX equation and then just copy and paste it into something. right? So if you just want to quickly get an interpreted version, that's pretty powerful. If you want to do your talk and you really want to get, for either your talk or your poster, lots of math and you want to do it in LaTeX, there's a package called Beamer, which will let you do nice tech-based layouts. This is really useful if you already have your paper written in tech and now you just want to use most of that for your presentation, then you don't have to worry about messing with it. There's a ton of stuff. LaTeX is pretty complicated. References in LaTeX, I'm going to go through this super fast because I'm going to show you a way I think will be easier for you to start with it. But if I want to have references in tech, I can have, so my mother is a fish, site WF, bibliography, bib item WF. Okay, no one in their right mind does this, although I still find students every now and then who do. This is not how you do something in LaTeX anymore. Okay, now it's important when you do this to understand that tech, because of the way it's processing as a language, reads a file called, so if this was called file.text, here this will read a file called file.aux to know what does this reference in the citation mean. First pass through this, it can't possibly know what to put in for WF because it hasn't actually seen the definition of WF, which is down here. So it's a two-pass process. First pass through, it's going to look for a file.aux. It's not going to find anything, or it's going to find it's not going to have WF. And then it's going to add in whatever the thing is next. Second time through, now it's going to find it, find the equation reference, and fix it. Okay? So because we're using these symbolic references, a second pass is necessary. I actually recommend when you do stuff, sometimes a third pass is necessary. Because when I fill in the references, I change the formatting, and references can move around. So especially if I do what's called a page ref, that'll really make things weird. But otherwise, my references, my table of contents and whatever, which refer to pages, can still be wrong. So if you use table of contents or a figure reference, then a page reference, then you really want to make 3 passes. Pragmatically, I recommend, if you're not using overleaf, overleaf will do all that automatically. If you're using your own base version, I recommend you use make, which is how we do our papers. We use make files. And then we just say make the paper, and you just go in the direction, you say make, it runs the default all, it'll run LaTeX, run BibTex to update your bibliography references, run LaTeX a couple of more times, and you don't have to worry about any of this. It just does it all automatically. This basically says, ignore errors, keep going. If you don't put that in, it'll stop on the first error. I actually often don't let it go past the errors, because sometimes it's worth fixing them. Otherwise, you just spend time waiting for it to compile. But so after you do all of that, if you do a tutorial, you get something like my mother is a fish with the square brackets, and that's in this base bibliography. But as I said, no one in the right mind does raw bibliographies or BBL methods. It's burdensome. How to format them is up to you. It's difficult to reuse references. Just a bad idea. After tech came out, and unfortunately after my thesis, BibTex came out as a tool to bolt on and make it a little bit easier. So I'm not going to teach you all of BibTex. I'm going to show you a bunch of examples, but even this has now been supplanted now with some tools that make it a little bit easier. So BibTex is a plain text file designed to work with LaTeX, and it basically incorporates a bibliography database. So I have a database, actually I have many of them, but I have one that's got like 4,000 papers in it that sometimes I will just include, and then I can cite any one of those 4,000 papers. I've actually stopped doing that just because I can't remember which ones were. I always have to search for them. So now I have often a per paper version, but it's easy enough to make as big or a smaller one as you want. You can actually include multiple things, which the original version didn't. That's why I had a giant file. Now I can have 5 different bibliographies, and I can say search this one, or this one, or this one, and this one. And as long as you don't have conflicts, it'll gladly find whichever of these the paper I refer to is in, and then put them all together, which makes it a little easier to keep them compartmentalized. The disadvantage of trying to use this from scratch is it's really got a pretty steep learning curve. Many students have complained to me, but there are tools and source things to make it easy. Here's an actual reference, which is unfortunately really ugly because I didn't get it laid out right. So there's an article with an author, title, journal, volume number, whatever, all these different sections. And there's things besides articles, there's books, PhD, theses, there's a whole bunch of things that are defined. If you use Emacs, anyone here use Emacs? No, I'm alone. Okay, then I won't spend a lot of time talking about it. Emacs is my favorite, but also very old text editor. It has modes for all these, and I can just say MetaX book, and it knows if I'm in a tech file to just add a book entry and fill in all the fields for me. So those things make it a whole lot easier. When I go to use BibTex, it's a standalone program that reads your .aux files and what's called a BST file for a bibliographic style file, and then uses that to produce the .bbl file that's read by Latex to read in. It can be complicated to put them all together. Many times of things, articles, books, tech reports, PhD theses, each of them can have some subset of these fields, and they get to be complicated. So here's a book. It has what's called the key. This is how I actually refer to it. So I would cite this by saying /cite press. The author, title, the publisher, the year, and then it'll have optional things I can add. Here's an article. It has some things are required, some things are optional. Article is by far the most commonly abused type. So if somebody gives you something that's an article and it isn't an article, you probably should change it to something else, because the rules for formatting for whatever they use it for might not care, but if you format it for something else, it might actually care if it's a proper thing. So using a conference proceedings or in proceedings or something else. Tech reports, PhD theses, in proceedings, which is what a conference would have, which is sort of saying book title, and this is one of the differences. You normally say, what's the name of the book? The book title is not the same as a journal title when you go to actually do things. Lots of formatting files, so you can get all of these again at CTAN, these things called style files and BST files that lets you have lots of different formats. If you do a basic install, you get all the basic ones anyhow. If somebody says, wow, can you get me the Geometrica journal style, that probably did not come with your Tech Live, but if you go to CTAN, if they told you it's a style file, you'll find it. It'll be there. You invoke your style in the thing. So for example, I wanted to use MLA as my style. I can say use package MLA. Then I say bibliography style MLA. Bibliography my bib. This is the name of my database. And then in this case, I can say no cite star. This is a special command that people in humanities use but are rarely found in science, which is include all the references in this bibliography, even if I've never referred to them. Okay. Generally, we consider that really bad style, but apparently they do that all the time. So it's a command. It's there. After you do all this, you can get a section that looks like works cited, which is funny because that's the default title under MLA, despite the fact that people will use star, which means it would never actually cited. So it's a little bit funny. And then it'll get some formatting. If, however, I wanted to change it to AMS plain as my bibliography style, so the only difference here is I didn't include anything because it's a default style, and I said AMS plain. Now, again, I have the star. I get something whose section is called bibliography and has all the references, and now they're by number, right? So they're no longer by name. In this style format, everyone has name, 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 okay? As opposed to APA, which would be name, 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 date, and then stuff. So every different journal or style or field has different styles of citations. You want to go ahead and use those. So in your first assignment, you will use IEEE. I will actually use multiple different ones over the semester to force you to undergo the pain if you've not done it right. So I'm not going to go through all these. You get a bunch of different things. So that leads us to the next thing, right? Today, I'm telling you, right, I don't recommend you do bibliography files by hand. I recommend you use a tool to manage your references. This becomes very useful because if you're sharing references with another person, you now have textual files, who's adding one, what is going on. The other is, with this kind of tool, you don't have to remember how to fix them. So Zotero is the tool I'm going to recommend. And with that, you link your citations to your bibliography list. You have a database. It really is a database. You can search through it. You can do a bunch of stuff. And importantly, you can put them together. And I have no idea why this slide is here. Oh, because I'm going to show you some. As I mentioned, this is just the other Zotero slides were out of I recommend your document have multiple includes or inputs. The difference between include and input is like a text, a CPP macro says, load this file and shove it exactly here. Include is a little bit more sophisticated. It loads the file, it shoves it here, but it puts a blank page between them. Include is for like chapters, input is for pieces. And since in this document we just want inputs, we just have inputs. I already showed you a little overleaf. So with overleaf, I can get stuff out to GitHub. I can do a bunch of things. One of the things I didn't show you is there's a command up here someplace. So where I can actually look at the history, so I can see. So what it doesn't show you is all its internal commits. It only shows you commits where a new commit flag was added. So internally, it might do 50 different little commits. And if I look at my history, I can go back and edit any one of those and go back a couple of steps. This is because my student works in overleaf and I work in my machine, and I do real git, push, and pull. So each of these were my commits. You can't actually see his, despite that there were a bunch in between. And then I can push or pull it as I want to do that. Oops, not what I wanted. So Zotero, that's the next tool I'm going to cover. Hopefully I'll get through this quick enough to have a little bit of time for Git. So Zotero is going to help you manage a lot of references. It's actually free. There's another one called Mendeley, which is free and okay. If you're just using Word, Mendeley does not have as good support for BibTex, so I'm going to recommend just Zotero. And then there's a bunch of things that work for just Windows and Word. Zotero runs on multiple platforms. I think Reference Manager does too, but because there's now Word for Mac and everything. So Zotero, you go to Zotero.org, you download it, you get a bunch of things. But one of the reasons I like it and I'm recommending it is it's not just about bibliographies. It actually extracts a bunch of other information, metadata from these sources. For example, you can get it to store a copy of the PDF. If I say add this reference and there's a PDF, when I look at it in Google Scholar, it will save me a copy of my PDF in my Zotero references so I can deal with those. It'll create a bibliography for Word or OpenOffice, and it can also export it into BibTex for LaTeX. So if you are forced, like me, for various reasons, to do multi-platform LaTeX and Word, it really becomes useful. It allows you to have shared libraries for your organization, class, or research group. So I also use this when I'm doing joint proposals, even when the proposals are in LaTeX, because it allows me to have a consistent bibliography with my partners who might be at another university. They add a reference, I add a reference, it keeps them all up to date together, instead of me having a single bib file that I have to then share with them, and then if I forget to send it to them, it causes them problems. Now, if you're doing everything in Git and you're having a shared repo and you do it right, it generally works out and you don't have to have this, but for some reasons you want to be able to use it, it's okay. So Zotero, you can get there's both a standalone program and a connector. When you download it, this is in Windows it'll look like this. It actually looks pretty similar. Oops. Oh man, I had no idea. You can't see the bottom or the top of my slides. Well, there's nothing I can do about that now. I will have to have a conversation with campus about that. So there's a little icon. I can't see my icon. Well, it's basically a Z in a six-sided hexagon. Okay. The most important part is once I have Zotero installed, there's this little folder up here, and I have Zotero and it's loading. And if I go to actually add references, I can do them manually. So I can go click on the Zotero reference in the app, and I can say add any one of these, and it will add a reference in my Zotero, and it'll properly format that when I go to export it. So it'll give me, like, here's the conference paper. I can type in the title. It shows me a bunch of fields. I have to fill in a couple of them. Others are optional. But by far its most important use is that I can actually use that little folder guy, and depending on which version I'm using, Mac or Windows, and most of you are Windows users, so I figured I'd show you that one first. I can click on this and I can say, oh look, save things using PubMed, using DOI, save it in a bunch of different places that I have set up, and it will let me download anything I'm looking at in any of the standard places where I can search for paper, PubMed, Google Scholar, whatever, and then I can do that. So here's now a version, this is in Mac. If I click on the little folder guy to import stuff, there's a couple of references here on the page. If Zotero's not running, it'll yell at me. If it's running, it'll show me which of these items that are on this page do I want to import into my library. I click the little checkbox, hit OK, and now those are in my bibliography. And when I go to add things, I'll get to showing you exporting bibliography in a second. But that's how quick and easy I can download stuff from Google Scholar and stick it in my references. And I have all my references. If you never cite them, it doesn't matter if you add them. The one thing is you can also get it to attach stuff. So I can attach, and you can set up as a default to attach always or never, and then you have to override it. So I can say add an attachment where I can add a link, store a copy of the file, add a link to the file, whatever in my bibliography. So later on, and if you're like me, you'll have this problem all the time. It's like, I read this paper. Where is it? I have no idea what the name is or who the authors are. I can actually go into Zotero and I can do a keyword search over the papers I have in my bibliography, right? Which is actually very useful for me because I can never remember where I read it. It's especially tricky since I read lots of things that aren't published and I can never find because like they're for review. You don't keep a copy of them, I just know I read them. So the other part which is really useful is I can, for anything I have in my Zotero file, I can actually click on this little tab that says notes, which you probably can't read, but it says notes. And then I get a box where I can type notes about that paper. So when you're looking through lots of papers, this gives you a place where I can say, add this paper to my reference library. Here's my comments and notes about it, and keep them together instead of having a text file here and some references and hoping they come together. And then later on when you go to search, you can search through everything. You can just for titles, you can search through notes, you can force it to help you find those things. So if I want to create a bibliography from Zotero, if you are for work reasons forced to work in Word, or that's what you really like, from Zotero I can either export it as a bibliography, as raw text, RTF, rich text file, HTML. I can copy to the clipboard, or I can export the references into BibTex file, which I'll show you first, and then I'll talk about word integration a little bit in a second. So basically I take a bunch of references and I can control click and choose whatever ones I want, or I can export all of them and I can say create bibliography from items. Okay, if I do that, it'll try and give me a choice of some various files. I can also take an entire library. I can export the library. If I want to export it, it'll ask me a choice of formats, one of which is BibTex. I export it, I get BibTex. If I am working in Word and you really want to also share these, or OpenOffice, there's plugins for both. You can then basically get a new little menu that shows up. There's a little Zotero menu item. When I click on it, it tells me, do I want to add a citation? Do I want to insert a bibliography and whatever? As I do any of those, I can set preferences. I can choose like the style of the document or the bibliography I'll show you in a second. I can then insert references or insert multiple references. And now Word will automatically keep these up to date. So when I add one more reference, they all, if they're numbered, they all get renumbered according to the rules of numbering, which is different between AMA, which is numbered in alphabetical order by author, versus IEEE, which is in order of reference, or maybe it's the other way around. I can't even remember which is which now. One has one order and the other is a different. But anyhow, you put these in. When I add a citation, I can choose its style, click on a reference, and I add that, and then if I really want to add a page number, I can even include a page number, and it will add that into your document. Say, in this case, which is the Vancouver style, they use open parenthesis and a number. Hopefully they never have equations, because that would be really confusing if you did. Or you can insert things, and then at the end, when I insert the bibliography, it'll just put them at the end of the file. Now when I insert another thing, it'll automatically update them. So this makes references in Word a little bit more palatable. Generally, Zotero has a wide selection of the most popular. There's also a repository of even more styles, so if I want something a little bit more esoteric, like the Harvard reference format, you can install it and then have other formats. Zotero allows you to have a library as a web account. Given that, you can actually have libraries of multiple bibliographies which are useful when you're sharing them across multiple people. We already talked a little bit about Overleaf. So Overleaf actually has a way to link in down here your Zotero bibliography, which makes it so that you don't have to have separate bibliography files in Zotero or in Overleaf. It knows about your bibliography and it'll just start pulling them out of there, so you don't have to do as much work to generate them. Some screencast tutorials of how to do stuff in Zotero if you want to get more details. They support groups, data syncing of libraries, and putting them all together. So how many people don't know Git? Only a few, right? So I'll post, because we have like 5 minutes left of class. Git will take me longer to do an intro. I will do a little bit more next class, but I will send, here's enough basic Git, like to get your library, your account created. So you should have received an email from Git. Has anyone, I know Terrence, or sorry, Sim, did you get it or not? Okay, so you got an invitation. If you click on that, and if you go to the PAC Education, which is the link inside of Canvas, you'll get your free student account with private stuff, and then you can go in and create. So maybe actually I'll go ahead and do a quick. Did I already do the Git demo, or was that my other class? Did nothing with Git, right? Okay. Dang, that's what I wanted to do. Okay, so any of this, so somewhere here I can't, so I have a more complicated account. You'll probably only have one group. I need to choose my group. Which group am I in? So does one of those say bold class? Oh, okay. So here now, I don't want the dashboard. I don't know, thanks. I don't care. Although maybe you might want that. So now I can go in here and I click on New Repository. And it's going to create it's going to ask me for a name, a quick description, and I can choose to make it private. Then it's only shared. It'll only, in your case, it'll all be shared with me because this is my organization. Now the other thing you can do is, so once you have this set up, you can go in and you can put your CS6000 papers in here. So my recommendation is make a repo for this entire class, right? And then everything will go in that, and you can make what's called submodules inside a repo. And then once you have this link, you can go back into overleaf. That's overleaf. And I can do somewhere over here. Oh, once I have a project, right? Well, this one already has one. Let's go back out. So Amazon did not have a Git repo attached to it. I can go back over here. I can't see which one to do. But I just click the word delete. It's not good. Luckily, there's an undelete function, so I click on that thing over there. So then I can say GitHub, and now it's going to say create a Git repository. So it's going to ask me who to log in, what's the name of the repository, whatever. I can also tell it to make it private. So you can make your Git repo once you have your right account from inside Overleaf if you want to, and it'll link the two of them. And then you can actually bind it with an existing repo. I just didn't have to go through all that. So for your homework assignment, that's what you're going to need to do, is have a Git repo with your paper in it and put everything in. If you are struggling with that over the week, send me email. I will help you walk through all of that. So, I have more about how Git really works because I want you as computer scientists to really understand Git and what you can do with it, because Git is also useful for your code and a bunch of other stuff. Because how many of you have ever said, gee, I wish I'd saved that version 10 minutes ago? If you haven't, you will eventually experience that. With Git, so I saw those faces about like, Git can have 1,000 versions. It doesn't really cost it much to do lots and lots of versions. So if you're working on code, one of the things I like to tell my students is, if you're going to compile it and run it, you should commit it, right? And it sounds crazy, but you can have local commits of 100 versions, and then every time you can have it. But when you go to do experiments, you'll want a lot more of it. So we'll talk about that next class. See you next week. Thanks. So in this class, whether or not you want to make your repos public or private is up to you. Some companies care about things like that. So if you're working for a company, go whatever the policy is, you can make everything private. But if you want to have it look like you're being active on GitHub, public repos look like you're active on GitHub. And if you're going to look for a job in a year, companies will sometimes look at your GitHub activity to sort of see how active you have been. On the other hand, if they look at it and it's like, this is a public repo with papers from a class, I don't really care. What they're really looking for is meaningful activity on GitHub, not a bunch of your own personal papers. So it's not going to make much difference if you go either way.
Using our UCCS emails for the Git repo, or can we have you send it to our other repos?
So I don't know if so you can try. So the way I read their instructions was conflicting. So it might be I can link to it, but you're not going to get free private repos unless you use the UCCS one. So send it to me, we'll find out. Okay. Their instructions were very ambiguous about what it is. They tell, here's the instructions to give you students, you say to use it. That doesn't mean it won't automatically happen if you're in my group. So
okay, so I'll send you a link to my Git repo and then send me an invite, and if I can create private repositories, I'll let you know.
Then you'll know, because you'll find out, like, oh look, I have free private now, right?
Cool.
And you'll have to be in the right group. So I'm going to send you so it may be your private account can't, but when you're in my group, you can.
Right. Yeah. So okay, cool. Thank you.
Your games ever get back to you?
No.
Nice.
Well, actually, I can't say. They didn't get back to me before class. Ticket created. No, that's the last thing I got from them.
I'm trying to see what picture they have.
I know there's always some pictures.
All right, cool.
Hmm?
I used to Lex.
You use what?
The Lex.
Lex? Yeah, I don't care. That's
Yeah,
fine.
yeah. So with Lex, I can go through your classes.
Yeah, you can do all your papers. Lex is just a
Yeah.
different GUI. So I chose
Yeah,
overleaf because it's free. It has so the one thing. So you will have because I don't think Lex has GitHub integration. So you have to do your own GitHub and do all that stuff. But that's fine. I don't care.
Thank you so much.
Yeah, I was just trying to make it easy for people. Lex is, I think, right, because you'd have to do GitHub separately. It's like, let's just start with something that's all integrated. Okay.